As a reminder, we are going to take TSI on the 8th and the 9th. That is, that's not next Monday, but the next. So not next Monday, but the next. So we need to make every day count. Hopefully we can get passing by TSI then, and then the rest of your senior year is cake. Before we get started, we're going to remind ourselves, thanks to Sonia, of the song, because we're doing some mean and median. It was you, right? That told us. Hold on, got to get this volume. Maybe just click out and then click back in. That's really weird. Maybe I can reset it. Yeah. Okay. Remind me after our lesson today. Okie dokie. So we got to remember what these things are. Question 1 and 2. So it says find the mean and the median. Find the mean and the median. So what is the mean? Okay, so what's the mean? Add and divide. Very good. And what do we do for the median? What is the median? Sing it. What's the very first line? Say the very beginning of the song. Yes, median's middle. So for the median, you have to put everything in order, but for the mean, you don't. For the mean, you just have to add everything up. So let's add everything up. So I told you guys you would need a calculator. I'm not doing this for you. You need to add these up. Yep. So if you add them all up, you should get 6, 6, 6, not on purpose. That's just what you get. How many things are in the list? Yep, so we will divide by 9. So we've got 666 divided by 9. What do we get? Does that seem reasonable to have an average, taking a look at these test scores, to be 74? Yeah, I would say so. So there's our mean. And then for the median, you have to put everything in order. So I'm going to put this list in order. You should put the list in order. So I'm going to start with the smallest one. To find the middle number, one thing that you can do is start marking them off on each side one by one until you get to the middle. So if I start marking them off until I get to a middle number. So I have to go side to side, marking them off until I get to a middle number. And in this case, I just have one middle number, and that is my answer. Did y'all get 71 as well? Yay! Okay, for the next one, we're gonna do the same thing. Hopefully I can have a volunteer to put the mean and the median up on the board. What do you mean? Yeah, so when we put the mean, we have to add everything up and then we divide. Beautiful, good job. Let's see if we can get a volunteer for the other one. For the second one, you can just write the answer that you, because it's rewriting all the numbers. All right, good job. Yes, the mean is 78 and the median is 81. That is what I got as well. Okay, I'm gonna give you a couple of minutes to see if you can get the next two in your homework set or in your worksheet.
Is to add the numbers together from divide by how many numbers there are.
Yep. All right, before we move on, we're gonna listen one more time. Song. Bye. All right, the next section. It says a band has 12 trumpets, 10 flutes, 16 trombones, and 7 tubas. What is the probability that if 2 people were picked out of the band, and we've got 3 different situations. Part A, it says the first student plays the tuba and the second person plays the trumpet. Well, if we're pulling them out of the band, we need to know how many there are total. To do probability, it is always the part out of the whole. So we need to know how many are total. Very good. We got 45 in the band. So it says that the first student plays the tuba. So the first person plays the tuba. How many tubas are there? 7. So we got 7 out of 45. The second person plays the trumpet. How many trumpets? Here's the thing though. If I have 45 people in the band and I just take away 1 tuba, how many people are left in the band now? Yes, so the second fraction has to be out of 44. So anytime you're drawing 2 things, the second fraction will always be 1 less because you just took 1 away. So we will multiply straight across because that's how we multiply fractions. So use your handy dandy calculator. What's 7 times 12? And then we've got 45 times 44. All righty. So we want to list this as a reduced fraction, as a decimal, and as a percent. So the easiest one to do is obviously the decimal, but we also need to be able to reduce. So you can start with, they're both even numbers. You could start with dividing them both by 2 and then see if you can reduce any further. Did anybody get a reduced fraction yet? Mm-hmm. Very good. 7 out of 165. What's the decimal? And 0.04 as a percent. What is that? Very good. I'm going to give you a couple minutes to do the next 2. Down at the bottom is a two-way table. The two-way table means we can read it two ways. It says a study was done of athletes stretching and injuries in the past year. The table shows the results. What is the probability that an athlete, part A, what is the probability that an athlete stretches? So to figure this out, we have to find the title that says stretching. So it's here. So it says the probability that we're going to stretch. Okay, well, how many stretched? Reading down the columns or reading down the row. First one is somebody stretching and they get an injury. The next one is no injury and you were stretching. And then all the way down at the end is the total. Well, all it says is that people are stretching. So we need all the people that stretched. There was 350. What is the total number of athletes in this study? 800. So the probability that they stretch, it's the amount of people that stretched out of the total number. It's part of the whole. So we're going to do the same thing. We're going to find a reduced fraction. We're going to find the decimal. We're going to find the percent. So it's kind of easy to get started on this one for the reduced fraction because the first thing that you can do is start marking off the zeros. Anytime zeros match up, it becomes 1. So really you're reducing 35 over 80. Yep, you should get 7 over 16. And what is that as a decimal? Okay, so I get 0.437, so that would be 0.44. And what would that be as a percent? Hello? Uh-huh, I do. Sure. Uh-huh. And then you need to go and pick up a form. I wrote it down on this so you would remember. You're going to F108.
If I won't be present.
The next one that we're going to do together is part C. For part C, it says, what's the probability that an athlete who doesn't stretch doesn't get injured? So for that one, we have to look at no stretching. So doesn't stretch and doesn't get injured. So that's that number. And we also had to look at the total who doesn't stretch. So no stretching. The total for those that didn't stretch was 450. So the total is 450. And the part is describing who doesn't stretch, who doesn't get injured. So that is 219. Again, we're going to reduce this fraction. Let me know when you get a reduced fraction. So let me know when you get a reduced fraction. Very good. And what is that as a decimal? What'd you get? 0.4 what? Very good rounding. And then we would say that that is 49%. Beautiful. I'm giving you 3 minutes to see if you can do the other two from this section. Hello? Hey. Uh, hold on. Let me see where they called from. I thought it was F. Maybe it's F2. Let me double check. Oh, F103. Thank you. Bye. All right, we are about to move on to the back side of the worksheet. But before we go. So that we remember. Beautiful. I hope we remember that next time we take TSI. On to the back. It says a sock drawer contains 8 red socks, 6 white socks, 12 black socks, and 4 blue socks. If one sock is taken from the drawer, what is the probability that the sock is blue? So again, probability is the part out of the whole. So how many socks are there total? All right. If there are 30 socks, then it doesn't matter if they are blue or red or white or black. They're all going to be over 30. So how many blue socks are there? 4. Okay, so blue socks would be 4 out of 30. What does that reduce to? Very good. 2 out of 15. What is that as a decimal? Which would be 13%. The other one that we're going to do together is whether or not they are red or black. So there's still 30 total, but red or black, we have 8 red and we have 12 black. So 8 plus 12 is 20 out of 30. Pretty good chance you're going to get a red or a black sock. And if we reduce that, again, anytime that you have zeros that match up, you can mark them out because that just becomes 1. So it looks like it's going to be 2 out of 3. What is 2/3 as a decimal? 0.67. And that is 67%. So I'm going to give you a couple minutes in this section to see how many you can get. All righty. The next section. It says in 2010, a small college has an enrollment of 9,500 students. The declared majors are detailed in the table. So there are humanities majors, math and science, education, arts, and undeclared. The college created an incentive to increase the number of humanities and education majors to more than 30% of their students. How many students will have to declare as education or humanities in order for the college to reach their goal? So we need to know how many total students there are. So to figure out what 30% is, we need to know how many students are there total. So we have to figure that out first. Actually, I lied. You don't have to do that. We need to figure out 30% of. Yeah. No, we have to figure out the total. Yeah, I didn't lie. Figure out the total. So we have to add everything up. So tell me when you get a total. So how many total students are there?
9,500.
Very good. So if we want to find out 30%, we have to take 9,500 and then multiply it by 30% as a decimal, so 0.30. We need to figure out how many is that. All right, if they want 30% to be humanities, currently for humanities, there are 2348. So not quite 30%. So we have to figure out how many students will have to declare. So we have to find the difference. So we can subtract 2348 to figure out how many more students would have to declare a major for humanities. Logan got 502. What about the rest of y'all? Okay, so if they want more than 30%, then there would have to be more than, how much did you say? 502? More than 502. And they will reach their goal. So these, by the way, are questions off of the ACC final. So if you're taking the ACC final and you know how to do this question, which works exactly the same way, it's just different numbers, then you'll be awesome. The second question is basically the exact same thing. It says the college wants to offer an engineering major, but can only do it if at least 24 students majoring with at least 24% students majoring in math and science. Well, okay, currently in math and science, we have 861. Okay. How many students would need to change their major to math and science in order for the college to create the engineering major? Well, first we got to find 24% of the total. We already know the total. Total is 9,500. So we have to find 24% of 9,500. $2,280. Ooh, right now math and science has 861. That's not close at all, but we have to find the difference. And for this problem, it says at least 24%. So we'll answer just like that. At least how many? Did anybody else get 1419? Alex got 1419. Awesome. All right, it is 10 o'clock. We will grade our assignment at 10:15. So that gives you 15 minutes. Right now, you should be doing your homework, and I'm about to pass out your quizzes from last time because some of you need to correct those.